strongest force among all the basic forces is strong nuclear force, and it is 100 times greater than the electromagnetic force. Force of attraction between two charged particles when they are at rest is directly proportional to the product of magnitude of two charges, and it is inversely proportional to the square of distance between them. The gravitational force is nothing but the force of attraction between two bodies or two objects by the virtue of their masses. Hello everyone, welcome to session 2 of chapter 1 Physical World. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In session 1, we have discussed about the fundamentals of science, the meaning of science, what is the meaning of physics, and some interesting concepts. In today's session, we are going to understand what are the fundamental forces, which is the strongest force in nature, which is the weakest force in nature, and many more interesting concepts. So what are these fundamental forces of nature? The meaning fundamental is nothing but the basic. So there are 4 fundamental forces in nature, and they are strong nuclear force, electromagnetic force, weak nuclear force, and gravitational force. So the arrangement of these 4 forces are in that order from stronger to weaker. So the basic forces in nature are strong nuclear force, electromagnetic force, weak nuclear force, and gravitational force. Let us discuss about this. What is strong nuclear force? So strong nuclear force, the name itself says what it is. It is the strongest force among all 4 basic forces in nature. So where does it exist then? So it exists within the nucleus, which means it binds protons and neutrons inside a nucleus. So without any force, inside the nucleus, there must be a force which is required to bind these protons and neutrons. So without any force, the nucleus will be unstable. So this force is responsible for the stability of nuclei. It exists inside the nucleus, which helps in binding the protons and neutrons in it. And it is the strongest of all fundamental forces, and the force is attractive in nature. It is about 100 times greater than electromagnetic force. The strongest force among all the basic forces is strong nuclear force, and it is 100 times greater than the electromagnetic force. And as I said, this force is responsible for stability of the nuclei. And this is a very short range force because it exists inside the nucleus within the subatomic particles. So the next one is electromagnetic force. So the name itself defines electric and magnetic properties. Correct? So where does this force lies then? The force between two charged particles is electromagnetic force. So the force between two charges when they are at rest is called as electrostatic force. So the word static means rest. It can be calculated by the help of Coulomb's law in electrostatics. Coulomb's law in electrostatics is given by the equation F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. So the force of attraction between two charged particles when they are at rest is directly proportional to the product of magnitude of two charges, and it is inversely proportional to the square of distance between them. So this is equation given by Coulomb, and it is called as Coulomb's law. So the electrostatic force of attraction between two charged particles when they are at rest can be calculated by Coulomb's law in electrostatics, which you are going to study more about this in your second PUC. So charges in motion produce magnetic effect, and hence this combination produce electromagnetic force. When charges are said to be in motion, which means there is a generation of electricity. When charges move, there will be a generation of energy, and that energy is called as electricity. So electromagnetic in the sense when charges are in motion, they also induce the magnetic field. So motion of charges is nothing but electricity. When there is electricity, there will be an induction of magnetic field, and hence this combination produces electromagnetic force. So this force can either be attractive or it may be repulsive, because as we all know, like charges repel each other and unlike charges attract each other, and this is nothing but the force between two charged particles, and hence it can be attractive or repulsive. This force is stronger than gravitational force and weaker than strong nuclear force. So the next one is weak nuclear force. So weak nuclear force appears only in certain processes or certain nuclear processes like radioactivity. So it is nothing but the spontaneous disintegration of radiation from a substance. Yes, it is the force between elementary particles emitted during beta decay. So this force lies between the elementary particles that emits during beta decay. So what are the particles that emits during beta decay is an electron and a neutrino. So this force is stronger than gravitational force and weaker than electromagnetic force and strong nuclear force. So the next one is gravitational force. Yes, gravitation or the concept of gravitation is very familiar to all of us. So we know what is gravitation. So let us know few more things about this gravitational force. So the gravitational force is nothing but the force of attraction between two bodies or two objects by the virtue of their masses. Which means the force of attraction between any two objects that has mass is nothing but the gravitational force. It is the weakest force in nature. This is the very important thing, examination point of view. The weakest force in nature is gravitational force. All objects on earth experiences the force of gravity that is due to earth. Yes, we all experience the gravitational force or the force of gravity due to earth. It is always attractive in nature, and this gravitational force is called as universal force. Why it is called as universal force? Because it is applicable to all the things or all the objects in the universe. And this force is a long range force. Why it is called as long range force? Because it is applicable even for far away objects, or it is applicable to terrestrial and celestial mechanics as well. So the next concept is unification. What is the meaning of unification? Unifying, which means combining. So unifying the different forces in a nature is the basic quest in physics. Let us understand this unification by considering an example. A scientist called Maxwell, he unified the laws of electromagnetic theory and optics, and he explained the theory of electromagnetic wave, which means light is an electromagnetic wave. Optics is nothing but the concept of light. Electromagnetism is a different theory. Optics is a different branch. He unified both these electromagnetic laws and optics, and he explained light is an electromagnetic wave. And he explains the electromagnetic wave concept. In this example, the unification is between the electromagnetic laws and optics. So they combine together, and which gives rise to the concept called electromagnetic wave. I hope it is clear to everybody now. Unification is nothing but combining the different laws or the theories in physics, which gives rise to another different concept, and hence in this example electromagnetic and optics were combined together and results in electromagnetic wave concept, which is explained by Maxwell. Similarly, Sir Isaac Newton unified terrestrial and celestial mechanics and showed that the laws of gravitation is applicable to both the terrestrial and celestial objects, and hence it is called as universal law of gravitation. So let us now see the definition of unification. So what is this unification? How to define it? It is an effort to see a physical world as a manifestation of some universal law in different domain and conditions. Let us see few more examples for unification to understand this in a better way. So the name of the physicist Isaac Newton, the famous scientist Isaac Newton unified celestial and terrestrial mechanics and showed that same laws of motion and the law of gravitation applied to both the domains. In the year 1687, he unified the terrestrial and celestial mechanics, and he showed that this laws of mechanics and this laws of motion and the law of gravitation apply to both the domains. Similarly, Hans Christian Ørsted and Michael Faraday in the year 1820 and 1830 respectively, these are the two scientists. They showed that electric and magnetic phenomena are inseparable aspects, because as I said, with the help of electricity, the magnetic field can be generated, and when there is a magnetic field, electricity can also be generated. So these two, electric and magnetic phenomena, they are inseparable aspects of a unified domain, that is electromagnetism. In the domain called electromagnetism, we are going to study about these in two inseparable concepts, that is electric field and magnetic field. So the two scientists called Christian Ørsted and Michael Faraday proved this. They gave a special theory called electromagnetism, which is nothing but the unification of electric and magnetic fields. So next we have James Clerk Maxwell. So in the year 1873, he unified electricity, magnetism and optics also, and he showed that light is an electromagnetic wave. So in this electromagnetic wave concept, the three theories or the three domains are unified. They are electricity, magnetism and optics. So these are the few examples of unification. So next we have Sheldon Glashow, Abdus and Steven Weinberg. In the year 1979, they showed that weak nuclear force and electromagnetic force could be viewed as different aspects of single electroweak force. Observe this, electroweak force is nothing but the unification of weak nuclear force and electromagnetic force. So next, Carlo Rubbia, Simon van der Meer in the year 1984, they verified experimentally the predictions of theory of electroweak force. So these are certain experiments and a few examples for unification. So next we have the concept reductionism. So unification is nothing but combining different laws or different domains to give a different law. And what does reductionism mean? Reductionism is quite opposite to unification, explaining the properties of complex system. The meaning of complex is difficult. Explaining the properties of complex system using the properties of constituent simpler parts is called as reductionism. So it is nothing but a complex system, we can reduce them into simpler parts, and studying about the properties of those simpler parts in understanding or in explaining the complex system is called as reductionism. The name itself says reductionism means reducing, which means the complex system can be reduced to simpler parts, and each simpler parts explain its different properties in understanding the complex system. So the reductionism is nothing but explaining the properties of complex system by the properties of constituent simpler parts. For example, thermodynamics. So what is thermodynamics? It is a branch of physics that deals with the study of the system by taking it into consideration, which also includes the internal energy, temperature, pressure, entropy and etc. So thermodynamics deals with bulk system in terms of temperature, internal energy and etc. Yes, to understand that bulk system, we can reduce them into simpler parts by understanding the property of the bulk system by taking the temperature concept first, then entropy, then internal energy, then combining everything and understanding that bulk system is best example to understand what is reductionism. So next concept is conserved quantities. What is the meaning of conservation or conserved quantities? That means the quantities remains unchanged with respect to time. They remains constant with respect to time. Of course, in nature, there are some special physical quantities that remains constant in time, and they are called as conserved quantities. In understanding the laws of conservation, we must know what is the meaning of conservation, which means the quantities, which means constant. Next, we have laws. So what is the meaning of law in physics? So in physics, laws are the statements given based on the observation, explanation and analysis. Scientists will conduct the experiment, they will observe certain things systematically and they give the conclusion. So the conclusion is nothing but the statements given by them. So in physics, laws are nothing but the statements given by the scientists by their analysis, explanation and Observation. Now we came to know about what is conservation, what is the meaning of law. There are certain conservative laws in physics. For example, law of conservation of energy, which means energy can neither be created nor be destroyed, but it can be transferred from one form to another form. For example, hydro energy. So, with the help of water, we can generate electricity. So, hydro is nothing but the term which relates water. So, here the hydro energy can be converted into electricity, that's the other form of energy. Similarly, solar energy can be converted into electrical energy. So, which means here energy, we are not creating any energy, we are not destroying any energy. We are just transferring the energy from one form to another form. So, law of conservation of energy is one of the example for conservative law. So, few more examples are law of conservation of mass, law of conservation of linear momentum and angular momentum, etc. So, conservative laws have a deep connection with the nature. The laws of nature do not change with time and they remain same everywhere in the universe, and they are called as conservative laws. Now, let us see some physicists and their major contribution to the field of physics. So, Archimedes. So, what is Archimedes' contribution to physics? He gave the principle of buoyancy and the principle of lever. Similarly, we have Galileo Galilei, who gave the law of inertia, and also he contributed by his refracting telescope. Christian Huygens explained the wave theory of light. Sir Isaac Newton explained the universal law of gravitation, laws of motion, and also he contributed to this physics by discovering the reflecting telescope. Michael Faraday, who gave the law of electromagnetic induction. James Clerk Maxwell, he unified this electricity and magnetism, and he explained electromagnetic theory. Light is an electromagnetic wave. Heinrich Rudolf Hertz, generation of electromagnetic waves concept is explained by Heinrich Rudolf Hertz. So next we have J.C. Bose. He explained, or he contributed by his ultra short radio waves. We have W.K. Röntgen, who discovered X-rays, and J.J. Thomson, who discovered electron. So, discovery of radium and polonium and studies on natural radioactivity is done by Curie. Next, we have Albert Einstein, who explained the theory of relativity, photoelectric effect, for which he is awarded Nobel Prize. We have few more physicists who contributed with their work in the field of physics, and they are Victor Francis Hess. He contributed by giving the theory of cosmic radiation, and R.A. Millikan, the measurement of electronic charge, and Ernst Rutherford, that is the nuclear model of an atom. Ernst Rutherford explained the nuclear model of atom, and Niels Bohr is one of the other major physicists who explained the quantum model of hydrogen atom. And C.V. Raman, an Indian scientist, discovered inelastic scattering of light by molecules. Louis Victor de Broglie explained the wave nature of matter. M.N. Saha, an Indian scientist again, he explained thermal ionization, which actually revolutionized in the study of the star's evolution, the life of stars. And S.N. Bose again contributed in the field of quantum statistics. Pauli is one of the other major scientists, explained the exclusion principle. And also Fermi, he explained the control nuclear fission. Heisenberg, one of the great scientists, explained quantum mechanics and uncertainty principle. Dirac, another great scientist, explained the relativistic theory of electron, and also he contributed in the field of quantum statistics. Edwin Hubble, expanding the universe is explained by Edwin Hubble. Next, we have Ernst Lawrence, explained cyclotron. James Chadwick discovered neutron, a subatomic particle. We have Yukawa, he explained the theory of nuclear force. Homi Jahangir Baba explained about cascade process of cosmic radiations. S. Chandrasekhar is one of the another important physicist and a mathematician, gave the study of the structure and evolution of star Chandrasekhar limit plays a major role. So this is a list of few physicists and their contribution in the field of physics. Next, we have some basic principles involved in technology. Yes, applying the knowledge of theory for practical purpose is nothing but technology. Let us see some physics application in the development of technology. So the first one is nuclear reactor. So the principle behind the working of this nuclear reactor is the nuclear fission, controlled nuclear fission, which means the substance undergoes splitting, which means the process of splitting up of a nucleus is nothing but nuclear fission. So nuclear fission gives rise to a liberation of energy, which is the principle behind the nuclear reactor. We are all familiar with computers. The principle behind the working of computer is nothing but digital logics. Next, we have rocket propulsion, where the Newton's law of motion are applicable in the propulsion of rockets. And hydroelectric power, the name itself says hydroelectric power, the law of conservation of energy of different forms. As I explained, this hydro energy is converted into electricity. So hydroelectric power, which is very much required nowadays in the society. So in the generation of electric power, we use hydro energy. So in the principle behind this hydroelectric power is nothing but the law of conservation of energy. So next, we have aeroplanes. So the fluid dynamics. In the field of fluid dynamics, the role of physics is important. Bernoulli's principle is the principle behind aeroplanes. And optical fibers. Yes. So the principle behind optical fiber is total internal reflection. So because of this total internal reflection, we can avoid the loss of energy, and hence the name total internal reflection. Because the signals internally, they reflect totally, there will be no loss in the use of optical fibers. We have photovoltaic cell. Photovoltaic cells means with the help of light energy, the voltage can be generated, and the principle behind this photovoltaic cell is photoelectric effect. So these are some excitement and applications of laws of physics in the development of technology. So in this chapter, Physical World, we have come across what is physics, and we came to know what is the importance of physics in our daily life. And we have also discussed about scope and excitement of physics. We came to know what are the different fundamental forces: the strong nuclear force, that is the strongest force in nature; gravitational force, that is the weakest force in nature. And also we discussed about in nature, few quantities remains constant with time, and they are called as conserved quantities. The laws of physics, conservative laws, and also about some discoveries we have discussed. So the importance of this chapter, Physical World, is knowing about the basic concepts of physics. So this is about Physical World. In the next session, we'll discuss about another important chapter. Until then, all of you take care. Thank you.